Poly means many, and nomial means name or term. So a polynomial is an expression with many terms. It can have constants, which are numbers like 2, -10, 1/6. It can have variables that are like x, y, a or b, and it can also have exponents. An exponent is going to be this number to the right and top of the base. So the 4 in x to the 4th power is an exponent. For a polynomial, this exponent can only be a non-negative integer. The numbers like 0, 1, 2, 3, 4, and so on. It can't be something like 1/2, right? And it also can't be something like -3. So it needs to be a non-negative integer. And these terms can be combined together using addition, subtraction, multiplication, and division to create this polynomial. For example, a term in a polynomial could be 2x, right? We have our constant 2 multiplied by our variable. Another polynomial could be 4x cubed, which is going to be a constant multiplied by an exponent. And let's say we can use addition to add more terms. Like for example, 4x cubed plus 5. That's a polynomial. Something that's not a polynomial would be something like x to the -3. Why? Because the exponent needs to be a non-negative integer. And another thing to know is that you cannot divide by a variable in a polynomial. For example, something like 1 divided by x is not a polynomial. But this one's not a polynomial and this one isn't. While these two are. Like mentioned previously, polynomials are expressions with many terms. There are a few special names for polynomials with 1, 2, or 3 terms. For example, monomial is 1 term, binomial is 2 terms, and trinomial is 3 terms. There's also quadrinomial for 4 terms and quintinomial for 5 terms, but those names are not often used. A good way to remember these names is to think of cycles. For example, a monocycle is a cycle with 1 wheel, a bicycle has 2 wheels, and a tricycle has 3 wheels. Now, let's practice identifying whether something is a polynomial. Let's start here. We have 2x divided by 3. Is that a polynomial? Yes. Yes, it is. It's 2/3, which is a constant, multiplied by x, which is a variable. That counts as a polynomial. To be specific, it's a monomial because there's only 1 term. What about this one? 6x to the 5th power plus 3x squared plus 4. Is this a polynomial? Yes. Yes, it is. It is constants multiplied by exponents. And all the exponents are non-negative integers, so it is a polynomial. What about this one? 5x cubed divided by y. No, it is not a polynomial. And the reason it's not a polynomial is because it's dividing by y. So we're dividing by a variable here, which we can't have for a polynomial. What about this one? X squared plus x to the -2. Is this a polynomial? No, it's not a polynomial. Because here we have an exponent that is negative. For polynomials, the exponent needs to be a non-negative integer. What about this? We have 10. Is 10 a polynomial? Yes, yes it is. 10 is just a constant. And lastly, we have this. 6x minus 10, all divided by x. Is this a polynomial? No, no it's not. And the reason here is same for here. We're dividing by a variable here, so that is not a polynomial. When discussing polynomials, we often discuss the degree of the polynomial. The degree is the highest power of the variable in the expression. If a polynomial has more than one variable, the degree is calculated by adding the exponents of each variable together. For example, for this expression, we have 1 plus 2x plus 3x to the 5 plus 4x squared. The degree is going to be 5. This is because here we have a degree of 1 because it's x to the 1 power. Here we have a degree of 5 because x to the 5 power. And here we have a degree of 2 because x to the second power. And 1, 5, and 2, 5 is the biggest, so the degree is 5. For this one, we have 2x to the 5 minus 8x cubed y squared times z plus 4x y to the 8th z to the 4th. As we can see, our polynomial has more than one variable. So let's break this down. This has a degree of 5 because it's x to the 5th. The degree here, the degree is going to be 3 plus 2 plus 1. So 3 plus 2 plus 1 is 6. For this one, we have a degree of 1 plus 8 plus 4. That is 13. 5, 6, and 13. 13 is the biggest number, so our degree is 13. Now, let's practice by identifying each polynomial by degree and number of terms. Let's start with -7. -7, the degree is going to be 0 because we don't have a variable to a something power, right? So degree is going to be 0. Another way we know it's 0 is -7 can be written as -7 times x to the 0 power because x to the 0 power is going to be 1. And here we see we have one term. What about this one? We have 6y to the 7 plus 5y cubed plus 2. The degree for this one is going to be 7. The degree for this one is going to be 3. And the degree for this is going to be 0. So degree is the highest, so it's going to be 7. For degree, it's going to be 7. And as you can see, we have 3 separate terms. This one has 3 terms. What about this one? We have 2x minus 9y. This is basically a 1 here and a 1 here. So our degree for this one is 1. And our degree for this one is also 1. So our degree is going to be 1. And we have 2 terms. What about this one? We have 10x y to the 4 plus 2y to the 6 plus 7x squared. So this one, we have 1 plus 4. So this is going to be 5. This one's 6. And this one is 2. The biggest one is 6. So our degree is 6. And our number of terms is 3. What about this one? We have 4y squared plus 2y plus 5. For this one, it's the power of 2. This is the power of 1. And this is the power of 0. Our degree is 2. And we have 3 terms. For this one, we have 2x cubed plus 10. So this is going to be to the power of 3. And this is the power of 0. So our degree is going to be 3. And we have 2 terms here. Let's also practice how to simplify a polynomial expression when we're given a set value. For example, here we have -2 times a cubed plus a squared plus 8a minus 21. We want the value of this expression when a equals 3. We solve for this by plugging 3 in for all the a's that we see. Now, let's work through it. So we have -2 times 3 cubed plus 3 squared plus 8 times 3 minus 21. Now, let's simplify. So here we have -2 times 3 cubed, which is 27, plus 3 squared, which is 9, plus 8 times 3, which is 24, minus 21. This gives us -54 plus 9 plus 24 minus 21. So this would be -54 plus 9, which is -45, plus 24 minus 21, that's plus 3. So we know this is -42. What about this one? We have n squared plus 4n minus 12 when n equals -6. We do the same thing as before. We plug in -6 into n here. So we get -6 squared plus 4 times -6 minus 12. Whenever I plug in values, I like to plug in them into parentheses. That way the negative signs don't get confusing. So -6 squared is 36. 4 times -6 is -24 minus 12. So in this case, 36 minus 24 is 12. Minus 12 is going to be 0. Now we've reached our challenge question. Our problem is 2xy cubed plus 5xy squared plus 1 a polynomial? If it is, what is the degree? Let's start by simplifying this. It'll make it easier to identify whether it's a polynomial. Let's simplify this one. So 2xy cubed becomes 8 because that's 2 cubed, x3, y3. And then let's bring the rest of this down. 5x y squared plus 1. Now, taking a look at everything, is this a polynomial? Yes, it is a polynomial because we have constants multiplied by exponents here. And as you can see, we're not dividing by any variables, and we also have non-negative integer exponents. So this is a polynomial. Now, what is the degree? Let's start by looking at each term separately. So, the power of this is going to be 3 plus 3, that's 6. The power of this is going to be 1 plus 2, which is 3. And the power of this is 0. So the degree is the highest power, so we know the degree is 6. So, this is a polynomial, and the degree is 6. And that's the end of today's video. Thank you so much for watching.